In this video, we will discuss about example number 13 that says write a program to find out the factorial of a 5. You will study the concept of factorials in mathematics. Let us suppose n is a number. In mathematics, we write factorial like this in this manner, n factorial. Okay, this sign of exclamation is read as factorial. We will read this as n factorial, where n may store any natural number. So if n is a number, then n factorial will be written as n into n minus 1 into n minus 2 into n minus 3 into n minus 4 and so on. Okay, n minus 5, n minus 6 till this n turns to 1. For example, let us suppose the n stores and have the value 4, then n factorial, then n factorial, then n factorial means since n stores 4, this means n factorial means 4 factorial. Factorial of 4 means, okay, factorial of 4 means 4 into 4 minus 1, 4 minus 1 3, then into 4 minus 2, that is 2, then 4 minus 3, 4 minus 3 1. So now you can see here that the actual number that is stored in n, that is turns to 1, or this process will stop here. Now we have to multiply this. So if we multiply it, we will get the answer here 24. So this is the factorial of 4. So if somebody asks what is the factorial of 4, you will say 24. Similarly, if you want to find the factorial of 5, so factorial of 5 will be first 5 as it is, that is number as it is 5, then 5 in 5, 5 minus 1 4, then 5 minus 2 3, 5 minus 3 2, 5 minus 4 1, and this process will stop here, and we have to multiply all. We have to find the product of this, and that will be 120. So this is the factorial of 5. So in this way we find out factorial of any natural number. Remember this, positive natural number. Okay, so all these are the these are the two examples of how to find out the factorial. Similarly, if somebody asks you what will be the factorial of 10, then you will say 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And if you find out the product of this, whatever is the product resultant, that will be the factorial of 10. We will study this concept of finding out factorial in mathematics. Now let us create a program to how to find out the factorial of number 5. So we have seen the process, that what process is followed to find out the factorial. So same the concept we will use to create the program. We will declare here one variable int I is equal to 5. This program is given in a book, that is on page number 83, example number 13. Now here it will be int I is equal to 5, and f is another variable that is initialized to 1. This f variable is used to store the factorial, the final resultant, and where this value of I stores the number whose factorial we want to find out. Okay, so 5 is the number. So now for our first requirement is, if you multiply any number by 5, okay, by 1, then definitely you will get the number itself. Then we have to decrease the value of this I by 1. Next time it will be 4. If we decrease the value of this I by 1 every time, so next time it will be 4, then 3, then 2, then 1. So we have to keep on multiplying, okay, that value again and again. So this is the code, f is equal to f into I. This statement will be executed again and again. here value of I we have to decrease, because first time the value of I is 5, next time the value of I as per our requirement to find the factorial we have to multiply 4. So this means we have to decrease the value of 5 by 1. Next time again the value will be decreased by 1, it will be 3, and then 2, then 1, and we have to keep multiplying these values again and again, and this is that statement that will multiply the values, and this f will store the resultant value. Let us see how the loop will execute, and this loop will execute how many times? Till the value of I is equal to greater than equal to 1. And in the end, after the termination of loop, we have to print the factorial, that what will be the resultant value that f will store. Now let us, for the first iteration, what will happen? For the first iteration of the loop, when the first time the loop will execute, here the value of I and f is initialized to, I is initialized to 5 and f is initialized to 1. When this loop will be executed, what will happen? For the first time, the value of f, okay, when this body of do will execute, within this body of do, there is a statement. First statement is f is equal to f into I, f into I. Now value of f is, we can see here the value of f is 1, so here will be 1 into 5, value I is 5, so here the f will store 5. Okay, now next statement is I minus minus. I minus minus means I is equal to I minus 1. This means I is equal to, value of I is 5, so 5 minus 1, definitely the value of I will be 4. So now new value of I is 4. Now compiler will make the test condition. Remember the key point, the loop will keep on executing till the test condition remains true. Now test condition will be checked. Since the case of do while loop, test condition is checked in the end. So now test condition will be checked. Now the value of I is 4. So now test condition, this test condition becomes I greater than equal, this is the test condition, I greater than equal to 1. So this test condition becomes now value of I is 4. So this test condition becomes 4 greater than equal to 1. 4 is greater than 1. Yes, it is not equal to, but it is greater than 1. So definitely this relational operator will result in true value. So if condition is true, the body of loop will execute again. This means do block will again execute. So now second iteration of the loop will start. Now for the second iteration of the loop, now again we have to repeat the same steps. So now value of I will be, for the second iteration of loop, value of I. Now value of I is changed 4. This 4. The new value of I is 4, and the value of f, okay, the value of f is also updated here. You can see here f is 5, so it is f is equal to 5. Now this body will execute f is equal to f into I. Now value of f is 5 and value of I is 4. Now f stores 20. Now value of I will be decreased by 1. Now value of I is decreased by 1 means now value of I is 4, so 4 minus 1, 3. So this means the new value of I will be 3. And now again the test condition will be checked. Now this test condition becomes that 3 is greater than 4, again that 3 is greater than 1, again this test condition will result in true value. This body will again execute. Now the third iteration of the loop, now value of this is changed, we can see here value of f is changed and value of I. So we will use now the new updated value of I and f. This is the value of I, new value, and this is the value of f. Now again same process will be same statement will be executed within the body of loop. This is the body, and value of f is now 20. F is equal to 20 and value of I is 3. So f will store now 60. Now value of I, again it will be decreased by 1, that is I minus minus. So now at presently the value of I is 3, so 3 minus 1, 2. So now the value of I becomes 2. So this test condition, okay, this test condition becomes 2 is greater than equal to 1, that is true. So now again this, since this condition works in true, so again the body of loop will execute. So for the third iteration of loop, not third, fourth, sorry, here will be the third one. Now fourth iteration of the loop. Again for the fourth time the loop will execute. Now the new updated value of I is 2 and f is 60. Now this statement will be executed within the body of loop. So here will be 60 into 2. 60 into 2 means 120. F is equal to 120. Now again the value of I will be decreased by 1. This means presently the value of I is 2. So here will be I is equal to 1. Okay. Now this test condition becomes true again. Here value will be 1. 1 is greater than equal to 1. So now for the fifth iteration of the loop, now fifth time loop will execute. Why? Because this test condition is again true, because 1 is equivalent to, you can see here, 1 is not greater than, but 1 is equivalent to 1. So this condition will be true. So now value of f is 120 and value of I is 1. So let us, value of I is new updated value of I and new updated value of f. And now the statement will again execute. F is equal to f into I. So value of f is 120 and value of I is 1. So f is equal to 120. And now value of I will be decreased by 1. And now test condition. Okay, this means I is equal to I minus 1. So 1 minus 1, that is 0. Now value of I reaches to 0. Now look at this test condition. What will happen this test condition? So 0 is greater than equal to 1. So at this point the loop will terminate because this process will stop. At this point 0 is greater than equal to 1. The loop will terminate and the body of this loop will not execute because test condition comes false. And then compiler control will execute the statement that is written after the loop. This is the statement that is written after the loop. You can see here final value that f store is 120. So definitely here we have used f variable. So whatever final value f will store, that will be printed on the output terminal. And we know we have discussed that factorial of 5 is 120. So our program is correct. So we will be able to run this code. Definitely this code will print 120 on output terminal. Let us run it. Run this code. You can see here put as 120. So this covers up the explanation of example number 13.